In this video, I want to discuss the SinterCast cast tracker technology. It's a new technology that we've developed to control and to trace cores, core packages, and also castings in the foundry. In the previous video, we discussed the SinterCast ladle tracker technology. That's been running in production since 2015. And as we gained experience with ladle tracker, we started to think, what else can we do with this clever technology to improve the productivity and the efficiency of our foundry customers? And that's how the cast tracker was started. I'd like to begin with an overview, and then we can look at each of the individual steps in the process. So at each core cell, we will blow the cores and assemble them into a core package. We reserve one core to serve as a tracker core. We engrave a unique code on that tracker core, and then we insert the core into the core package. At this stage, we can't see the code anymore, but when we produced the tracker core, we printed a label in parallel, and we affixed that label to the outside of the core package. So now at any time, we can just scan the label on the outside of the core package, and we'll know the identification of the eventual casting. So looking at each of the individual steps then, here we see the engraving of the tracker core, the unique code on the tracker core, and the parallel label that's affixed to the outside of the core package. And before the core packages go into storage, we read them, and this is what we call the inception. Yes, today in the foundry industry, the traceability often starts on shipping, or in some cases it will start with paper records at pouring. But with the cast tracker, the traceability moves all the way back to the moment that the cores are blown and assembled into the core package. So we read them before they go into storage. Yes, we do that with a camera. You can see them here on the storage rack. And then when the cores come out of storage, they're set into the Flask. It's a simple thing, again, to read the labels on the core package so we know the identification. And also, it's simple for us to make the subtraction, and we see how long they've been in storage. If we want, we can also include information like temperature and humidity during the storage time. We know the identification of the core packages in the Flask. We can transpose that onto a radio frequency identification on the outside of the Flask. So before we close the Flask, before we put on the cope, we transpose all of the information to the RFID tag. So at this stage, we can't see inside anymore, but we know the identification of the core packages, and in turn, we know the identification of the eventual castings. And anytime that Flask moves through the line and moves past an antenna, we can identify the time and the identity of the components inside. As it approaches the pouring station, here you can see we have antennas to read which Flask is coming to the pouring station. And at this point, we make the handshake with the ladle tracker technology. So here you see the ladle tracking with the RFID tag on the back of the ladle, the antenna. So we know all of the history of the cores, and we know all of the history of the liquid metal. We can combine that into a single database, and every casting has a row in that database with all of his production history. And this is the difference between producing commodity parts in Industry 4.0, where every casting is an individual and he travels together with all of his data. We also can track at shakeout. So we just need to put another antenna at the shakeout position. We can see how long the castings were in the mold since the pouring time until the shakeout. And we can track things like stoppages in the line, or if they were in the line over a Sunday, for example. So the cast tracker can be used really for three different things. First of all, it's a process control tool, and we can identify the core age. Most foundries have rules for how old a core has to be before you can use it, so that it's not gassing off, so that it's not hot and sweaty anymore. And they also have a maximum age, so it hasn't become too old during the storage. So if we put a core package into a Flask that's either too young or too old, we can stop that. We don't have to pour bad castings anymore. We can also identify the time that the core packages are in the mold from the time that the Flask, the cope, is closed until the time of pouring. we can use this technology for better troubleshooting. Today, most foundries have paper records. When we see a defect in a casting, we have to do the paper chase. We have to try to link up the different papers from the pouring area and the melting and the core history. It's a very difficult and inefficient process. With Cast Tracker, all of that data is together in a single database. You don't have to do any chasing. You go directly to the metallurgical correlation. In the old days with paper, it's sometimes difficult to find out which ladle a casting came from. But with Cast Tracker, we automatically not only know which ladle it came from, but whether it was the first casting in the ladle or the third or the last. So we know the cast sequence within the ladle. And with all of this information, we can determine the root cause of defects, and we can implement control actions to prevent them in the future. So first, it's about process control. Secondly, it's about efficient troubleshooting to determine root causes, but it's also about traceability. Now we know the moment of inception, the core assembly into a core package. We know the birth, which is the casting. We know the shakeout time. And this code carries on in the casting to the manufacturing, the machining, the assembly, engine assembly, and all the way to the vehicle. So an OEM can scan the vehicle identification number on the windscreen of the vehicle, and he can know the minute that the cores were produced. And now today, when OEMs find a defective casting, they will frequently quarantine a shift or an entire day of production. But with Cast Tracker, it's only necessary to quarantine one ladle. Yeah? So we maybe go from quarantining 1,000 parts to quarantining 10. So it's a huge improvement in efficiency and productivity. And as I said before, we move castings from commodities to Industry 4.0 individuals that have their entire production history. It's a really exciting technology, and after 9 videos, you know what to do. Contact SinterCast.